Hello. I'm happy to see y'all, but I don't see anybody. But I hope there are many guys at the other side of the screen. Hello, hello, hello. Greetings to the world. Yes, I would like to meet you in person, but nobody likes Corona. So we have to live with the screen, on the screen, with the DFF, which is at least something good. And I would like to talk today about our working group at the DFF, which is called Durability Plus. What you have heard from Donald already, they are also looking in the OLED group into the topic of durability. What kind of durability? Optical durability. I mean, of course, the display first has to be performing well. What does it mean? It has to be bright, nice colors, sharpness, intensity, no flash on the screen. Well, when these engineers have done the job, eventually the display will become a product. What does it mean, a product? Maybe a screen in the car, a screen on the phone, a screen on your fridge, or a screen in the hospital, at the wall to control the light of the room, or in a surgery compartment. And you may imagine there are several requests on the product all of a sudden. How will they survive? And especially now, due to Corona, new loads have been added onto the product, onto the surface, onto the integrated product. That means now we also have to face disinfection chemicals on the surface. Not good for the surface, just can tell you so much about that story. And of course, people try to kill the Corona, but UVC works wonderfully, but also not good for our product, not good for the surface. So you have to ask yourself, will our product survive under those conditions? How to compare this, how to evaluate it. So we have started to look onto the first main loading scenarios by the human being. That's us. And the biggest load maker, troublemaker is the hand. Why? Because the hand will be in physical, in chemical interaction with the surface. And it will perform a touch motion, which actually is a hit on the surface. A hit on the surface means surface deterioration, not good for the material. So how much load can it take? It will have a swipe function. Well, you know it from your phone, how you interact, and it will have a zoom function. 3 different types of loads, which you have to singularize and to transfer from human physiology into machine language. Because you want to make a machine which will do exactly that in the lab and will tell you a number, analytics, how long will your product survive? And how long should it survive? Well, at least the warranty time. Why is it so important? Well, if a product fails in a car, the car driver will not bring back the display. He will bring back the whole car. And the car shop have to replace the display in the existing car. So you burn a lot of money. You don't want that. So you have to make sure your product survives at least the warranty. Our experience in this field started, or my experience in 2013, focusing on mostly telecommunication products. You know, these phones you have in the pocket. So there is already a lot of experience and skills in this field. And we have been asked to expand this know-how to the automotive industry, to the aerospace industry, to the smart home industry, because there are the same needs or similar needs. So you have it in a fridge, you have it in the stove, in a toothbrush, in a door elevator. Displays nowadays are everywhere. Last week I bought a spring robe at Aldi. This is one of these supermarket shops here in Germany. And in this spring robe from Aldi, there was an LCD display, a touch LCD display. So I don't want to say that there is a market which is declining in revenue, as the speakers before me said. I can just see there are more and more applications where the display will be integrated, maybe not for a high price, but they are going through our life. So what are the biggest damages which you see from this through human motion, which are visible? This is, you will see some surface deterioration, and a lot of these damages even are not visible to the human eye. The anti-gloss coating disappears, the anti-scratch coating disappears. How do you measure this? For this, you need a special analytics. So the first section, as I have said in our working group, Durability Plus, is a specification which deals with this fingertip abrasion testing, or fingertip abrasion use simulation in the lab, and the 3-function touch swipe zoom. This is done. So what are the next issues? The next issues and topics will be fingerprint and cleanability. The question, how much dirt stacks on the surface? Is the surface a theme for dirt, or does it repel the dirt? A number has to be identified. And if the dirt is on the screen, how do you get rid of it? Is it easy to clean, or is it difficult to clean? There are special methods which measure this, which simulate this, so that you get numbers. And the numbers help you to evaluate the coating, help you to evaluate the material. And of course, one of the urgent needs is disinfection surface damages by chemicals and by UVC. I already mentioned that. And of course, haptical communication with the surface. That means if you touch it, how do you get a sensitive feedback? By acoustics, by vibration, by an electrical currency, many options, by heat, many things. So we want also to standardize this in respect to evaluate. So the display is an important part of the product. And always remember, if the display breaks, the customer will not bring back the display, but the fridge or the elevator. So eventually you have to exchange the display in this product, and this will be highly costly. So you better produce a product which will survive the warranty time. So the protocol is needed to simulate the human fingertip and the hand motions as close as possible. So you have to think about a drive which is very close to our human motion. And for this, you have to look to the human body and to the human physiology. And then you have to translate this into mechanical engineering, electrical engineering, to design a machine so that this machine will do something like the human hand. And then this type of abrasion will generate a wear pattern, and similar to the field load. And what is it for? Well, it should provide a general guidance to the OEMs and suppliers that they speak the same language, that they do the same thing. Well, there are so many tests already in the world, and some of them, like the IEC DIN markings and leathering caused by rubbing of fingers and hands. This standard was designed for a mobile phone, not for a mobile phone, for a phone which has an electrical button and you push it. Well, this type of motion is not the motion you use on the display. And the other standards is test method for electrical displays, pure mechanical test, scratches, no soft chemomechanical load, no interaction, no chemics. So these two standards are not good enough if you want to simulate the touch swipe zoom on the display. So you have to note that none of the standards provide a real field scenario to simulate the durability upon human daily use. And this is what will happen to your product. So understand the human physiology The fingertip is viscoelastic. It's not a metal. It has a rough structure. If you rub your finger against your thumb, you will see it's fairly rough. It's an inhomogeneous surface condition. The motion itself with which you touch something, with which you hit something, is non-linear. Just think about it. Your fingertip is moving at something. This will be a non-linear motion. And of course, your skin is covered with dandruff, sweat, fat, lotion, human fat and sweat, and also additional, maybe some lotions, hand creams, whatever. And the impact on the surface is not 90 degrees, it's 45 degrees. You can just try it yourself, take a surface, and if you hit it with 90 degrees, it will hurt. And if you look to your hand, you see there is an angle, this 45 degrees. This is how we are touching something. It's made, the human hand is made like this forever. So the three motions will be the touch, which is an impact on the surface, very strong by these liquids, and the chemics on the surface will be pressed into the surface. The swipe motion is a fast rubbing movement with low load, and the slow rubbing movement with medium load. This happens for the zoom function. So you have to simulate each singularly. You cannot just say, I do some abrasion, take some sandpaper and just work on the surface. This is also an abrasion test, but has nothing to do with a hand abrasion. And you want to simulate the real conditions as close as possible so that the numbers you get, they can be used for the market. So touch, swipe, zoom. So we have finished this description, this cooking recipe, what to do and how to do. And in section 2, we will have the fingerprint and cleanability. This will be fired out actually this month, hopefully. And then, of course, the question of disinfection on the display. If you want to learn more about this specification, or if you want to get this specification, there are two options. You are a member of the DFF, then you call up our general manager, and he will be happy to forward that to you. Or you become a member of the DFF, or you make some kind of deals with Karl-Heinz Blankenbach or with some of the guys. If you have more questions, just contact us directly via the DFF, or in my case, you can also visit our institute, which is ispa.institute, which means Institute for Surface Product Analysis.institute. Thank you for your attention, and it would be great if you could also join our working group, because the more people are joining our working group, of course, the better the result will be. Thanks for your attention.